From the very early days of civilization, human mind has been fascinated by the mystery of the deep, dark skies. Myriads of brilliant points of light have kindled their imagination, from which the stories about the creation and origin of the universe started. In order to understand the process in a more logical way, efforts started by human mind have come out to be the subject of astronomy today. Originally, the only instrument available for studying these objects was the nature-given human eye. Later, telescopes and many other implements were added. Even other bands of electromagnetic spectra, from the ultra-short gamma rays and X-rays right down to long radio waves, are being used for studies of astronomical objects. Man has sent observatories out in space. But in spite of everything, the charm of the old type astronomy using optical wavelengths from a ground-based location is still retained. The essential instrument in an observatory is a telescope.
Telescopic astronomy began with Galileo, who used a simple refracting telescope. In the refracting telescope, light from a distant object is brought to focus by the objective lens. The eyepiece is used to magnify the image of the object. But today, most modern observatories use reflecting telescopes. In the reflecting telescope, a concave mirror is used to form the image. Parallel rays of light from the star are brought to focus by the mirror to form an image at A, which is the prime focus. This is the simplest form of the reflecting telescope. Other mirrors can be added to make reflecting telescopes of different types. One of these is the classic grain reflector. In this telescope, a convex mirror is placed at the top end. It directs the light back down the tube through a hole. The image of the astronomical object forms at B. Since the positions of the stars and other objects in the sky are well known, astronomers can direct their telescopes to any object they want to study. In India, we have 6 major observatories which use large reflecting telescopes. These are at Patiala, Nainital, Guru Shikhar, Jaipal Rangapur, Kodaikanal and Kavalur. The observatory at Kavalur is named after the late M.K. Vainubapu, a renowned Indian astronomer of our times. It is situated in a small hamlet in the Javadi hills of Tamil Nadu. Each one of these buildings houses a telescope. The Vainu telescope installed at this observatory is the largest in India.
Here at the Vainu Observatory, Kavalur, we have several telescopes operating. We have the 15-inch, the 30-inch, the 40-inch, and the new computer-controlled 90-inch telescope. This is a 30-inch reflector telescope, which means its main collector area is in the form of a 30-inch concave mirror, which is placed somewhere here. The mirror faces the sky, collects starlight over its entire area, and focuses the starlight somewhere up in the tube. At the other end of the tube, we have a secondary mirror which bends the beam backwards, and it gets focused in this plane, which we call the Cassegrain plane, where other instruments are attached. The optic tube is mounted in such a way that it can be turned in two different axes so that any point in the sky can be accessible. The whole telescope is housed inside a dome which can be rotated. It has a slit which can be opened to have access to any part of the sky. When the telescope has been pointed to any particular area of the sky, the astronomer can have a view of that area through an eyepiece.
Astronomers use telescopes to study a variety of heavenly bodies, such as the clouded yet bright Venus, the cold planet Mars, the giant Jupiter and its satellites, the ringed Saturn with its satellites, the comet West.
The main function of the telescope is to collect light over a wide area, concentrate to form bright images. But the important part in study of astronomy is reading the hidden message within the light beam. This is accomplished by the astronomer by use of several specialized instruments. One such instrument is a spectrograph. Like this works on a very simple principle of dispersion of light.
When light passes through a prism, it spreads out into a band of colors known as its spectrum.
The spectrum formed is photographed by means of a camera. After recording the spectrum, we can have information. What is the temperature of the star? What are the elements of which it is composed of? What are their motions? And a lot of many information which is required for astronomical studies. Sometimes it is necessary to have a photograph of the area of the sky. For that purpose, a camera is used.
The camera captures a variety of images of the universe. Modern optical telescopes are huge. This is the 90-inch Vainu telescope. It is situated on the top floor of a tower, 3 stories high. It is mounted on a massive structure weighing 115 tons. One end of the mount is shaped like a horseshoe, into which the telescope tube can fit. The mount and the telescope can be moved as desired. Placed at the lower end of the optic tube is a concave mirror, which is uncovered only when in use. The mirror is 2.36 meters in diameter. The astronomer has to climb several flights of stairs to reach a special observer's cage. The observer's cage is placed at the top end of the optic tube. A modern electronic camera is also placed in the observer's cage. An optical fiberscope helps the observer to locate the star field.
Vinagaran, ready? Now you move the telescope to Orion Nebula.
The movement of the telescope can be directed by the observer. So, sitting at the top end of this optic tube, the astronomer tracks the stellar object of his interest and guides the telescope accordingly. A raised platform enables astronomers to guide the telescope to its final position through a set of smaller diffracting telescopes. The entire operation of the telescope is controlled by a computer, which is also used for astronomical calculations and storage of data. Astronomers use such huge telescopes to study stellar objects like galaxies and clusters of galaxies situated at very large distances.
Using the telescopes and the instruments attached to it, astronomers read the hidden messages in starlight. Answers to many questions are sought. One of the important questions concerns the life and death of stars.
Stars are usually born among huge clouds of gas and dust. When clouds start contracting due to gravitational attraction, the temperature of the core rises. At this stage, protostars are formed. When core temperature rises still higher and becomes about 4 million degrees centigrade, nuclear fusion starts in the core. The cloud starts glowing and the star is born. High temperature stars appear blue. There are white stars and also yellow stars like the sun. This stage of the star lasts for a long time. At the end of this stage, the star starts growing bigger. Due to changes inside, its surface temperature drops and the star appears reddish in color. At this stage, it is known as a red giant. When this phase is over, the star starts contracting. Its temperature rises, but the total light keeps on decreasing until it appears as a faint star. That is the white dwarf. Some massive stars called supergiants do not quietly become white dwarfs. Instead, they blow up in a giant explosion. A supernova. The remains of a supernova may become a very dense spinning object called a neutron star. Supernova 1987A, the brightest in the century, was discovered in the Large Magellanic Cloud in 1987. The remains of a supernova can also be seen for many thousand years in the form of nebulae, such as the Crab Nebula, Vela Supernova Remnant, and the Veil Nebula.
This is how the glowing body of the star grows and decays. Sometimes the surrounding material condenses in the form of planets, as it happened in case of our solar system. To us, our solar system may appear huge, but the astronomers know that in this wide universe, the solar system occupies only an insignificantly small place.
Let's make an imaginary model of the solar system. Taking a scale, on which 1 centimeter represents 100,000 kilometers. On this scale, the Sun is a glowing ball of diameter 14 centimeters. The planets will be much smaller in size compared to the Sun. The Earth will be a mere speck of 1.3 millimeter diameter, and the largest planet, Jupiter, will be a 1.4 centimeter diameter marble. Pluto will be another speck, less than 1 millimeter in diameter. What will the relative distances between the Sun and the planets be in this model? On this scale, the Earth will be 15 meters away, and Jupiter about 78 meters away from the Sun. The farthest planet, Pluto, will be about 600 meters away. Proxima Centauri, the star nearest to the Sun, will be a glowing ball about 4,000 kilometers away. To understand this model better, let's locate these distances on the map of India. On this scale, the entire solar system would fit into Kanyakumari, while Proxima Centauri would lie beyond Kashmir. This is the typical distance between the stars. There are more than 100 billion stars in the Milky Way galaxy. It also contains clouds of gas and dust. This bright band of stars seen in the sky is called the Milky Way. It is only a partial view of the Milky Way galaxy. Being inside the Milky Way galaxy, we can't see it completely. However, astronomical studies tell us that it is a spiral galaxy, 100,000 light years in diameter. And this is just one of the galaxies in the universe. The giant telescopes of today have identified more than 100 million such galaxies or island universes. These galaxies are gathered in small and large clusters, stretching into a vast expanse of limitless space. The farthest objects detected so far are quasars, many of them about 9 to 10 billion light years away. In this vast universe, our solar system occupies an insignificant place. are a humble yet brave species traveling through the universe on a small planetary spaceship called the Earth.
The aim of astronomy is to understand the physical universe. From our old belief of universe surrounding our Earth only, we have learnt a lot. We now know that we are inhabitants of a small planet circling a very ordinary star, which is one among the 100,000 million stars in a whirlpool of stars, which is our Milky Way galaxy. And with our present day instruments, we have seen that at least 100 million such island universes are spread all over what is the limits of the universe. But in course of this search, the scientists have stumbled upon new truths. They have discovered peculiar ways, new ways how nature behaves, how nature manifests itself. And this has given greater insight into the laws of physics, the mysteries of nature. Such searches will continue in future, and many more new truths will come within the knowledge of man.